No one has the answer for V2. Anyone? Can you please mute yourself? Just type on the chat box. 1.047, Umeshan 0.9987 and 0.9937. I got one answer from Umeshan 9987, 9937, and you must also calculate the angles as well. But the answers are different from what I have. So I wanted to check it with you. For me, V2, I have 1.0005 at 2.65 degrees. And for V3, I have 1.019 at minus 4.89, actually, not 69. And V4, I have 1.005 at an angle minus 0.32 degrees. These are the three answers for the three voltages at the buses, V2, V3 and V4. Can everyone take note of it so I can go to the next step, which is C? Can I go to the next step? Okay, the next step is to calculate the voltages using acceleration factor. If you remember, if I go back to this one, choose a value of 1.6 as the acceleration factor and find these voltages after first iteration, meaning what we'll have to do, we'll have to use these voltages that we got after first iteration, but with acceleration factor now. So our formula will be like this: V21 using acceleration factor is still number 1 using acceleration, iteration number 1 using acceleration. So the formula is forward, not that complicated, V20, then the acceleration factor A, V21, that we got already, V21, that value that I gave you, and then minus V20. So put these values and calculate and tell me quickly V21 accelerated. The general formula for that one is Vi not Vi0 plus A times Vi1 minus Vi0. So can you tell me the V21 and V31 if you have calculated? We have V1 and V31, we have calculated it, and V20, V30, we have it assumed here 1 per unit at an angle 0 degree. V2, V3, all zeros are where 1.0 per unit and at an angle 0 degree. So if you put those values, acceleration factor is 1.6. So you should tell me the V21 accelerated and V31 accelerated. How I got the V2 is the formula is written here. V2 is coming from this channel formula. V21 is this one, Jakari? Is this one that you are asking? V21.
Yes, sir. I got a different value to what you have.
Yeah, I saw it last time, and if you just need to put the correct values of those. Let me give you the values for everyone so that you can check. The formula is clear now. V21 is equal to 1 over Y22. Y22 is 3.667 minus J11. That's right. And then P2 is 0.5. Q2 was given minus 0.2. So it will become 0.5 plus J0.2 on the numerator. And V2 was 1 at an angle 0 degree, its conjugate is 1 minus J0 now. So 1 plus J0 was the from original V2 0. Now conjugate is 1 minus J0, but it doesn't matter much because it's still 0. And then Y2 V1, Y2 was minus 2 plus J6, and V2, sorry, V1 is 1 at an angle 0 degree, then minus Y23, V30, Y23 is minus 0.667 plus J2 times V30 is 1 at an angle 0 degree minus Y24, V4. So Y24 value is minus 1 plus J3, V4 is 1 at an angle 0 degree. So if I put all those values, then I got that one. Let me just double check with calculator if it was checked. Let me just double check once again for this value. Yeah, it looks correct, but you can double check at home. So
No, sir,
I need now these three.
I said I made a mistake with the Y22 value.
Y22 is actually 3.667 minus J11. That's right.
Yeah, I used 0.67. I don't know where I got that value from, but yeah.
Yeah, you see here 3.67 minus J11. It should be correct now. Okay. So can we go to the next two values, V21 and V31 quickly? Who has these values? V21, V31 for accelerated. This value I'm giving you because we cannot waste much time at angle 4.24 degrees. And then if we go to the V31 accelerated, it will be it will be 1.033 an angle minus 7.73. So these are the two answers for this one. So that we calculated the Gauss-Seidel method for first iteration, and then we used the first iteration values for acceleration to accelerate it. Now these accelerated values are more accurate as compared to the ones that we calculated in the first place, because if we want to use the iterations of Gauss-Seidel method, we will have to continue until or unless we find that a defined tolerance value is meeting the requirement, meaning the difference between the two consecutive iterations should be smaller than the tolerance value. So in this case, meaning we don't see any change in the magnitude of the voltage as we go from one iteration to the next iteration. But if we do use the acceleration, it accelerates very fast and give us the V2 accelerator 1.000008. Okay, you can double. I double checked my values, but I will double check once again if you're getting 1.0088. Okay, so can we go to the next one? Okay, so the next tutorial is on this one. It doesn't show the diagram, but it gives the buses and the other parameters, quantities per active power, reactive power, voltage and bus type, etc. So what it's saying is something similar to the previous one, but not exactly. There is a constraint here, so it's different in one way. So how is it defined? So what it is saying is saying there is a power system, and for the power system the data are given in two tables. One is showing the interconnection of the buses and the respective admittances. So bus 1, 2 is having an admittance of 2 minus J8, 1, 3. There is interconnection. 1 minus J4 is the admittance, 2, 3, 0.667 minus J2.664. And interconnection between 2 and 4 having an admittance of 1 minus J4. Between 3 and 4 it is 2 minus J8, and similarly the other values for the buses P, Q and the voltages are in this table. So bus 1, P and Q are not known because it's a slack bus and its voltage is at 1.06 per unit at an angle 0 degree. Bus 2 is a PV bus, it has generator, so P and Q are not there, Q is not there, Q2 has some constraint which is defined in this A and B. I'll come to that one. So P is given 0.5, Q2 unknown now, and then the voltage is 1.04 at an angle delta 2, also the delta is not known, and then it's PV type. And PQ buses are given for 3 and 4, and for those P and Q are known, minus 0.4, minus 0.3, minus 0.3 and minus 0.1 for bus number 4. From these, what we have to do, we have to determine the voltages, meaning the voltages at these three buses for V2, V3 and V4, but there is a condition there. The condition is Q2 in the first place, the first one A, Q2 is in between 0.1 and 1.0. The second condition is that Q2 is in between 0.2 and 1.0, less than 1.0. So we have to know the Q2 value first, where it is. So to do so, we need to start knowing the Q2 value. First step is to know the value of Q2. So for that, the problem is assisting us. It's telling us that we can assume the flat voltage start, meaning the values can be assumed to be 1 at an angle 0 degree if it is not defined. So what we do, first of all, we need to determine the Y bus matrix. So let's find this Y bus matrix quickly. You find out the Y bus admittances. You find the Y bus. Who has the value of anything?
So it's in the chat.
Y11 is, yes, I saw it. Thank you very much. So Y1 is 3 minus J12, which is correct according to my answer. Y12 is also correct, minus 2 plus J8. Y13 3 is minus 1 plus J4, which is correct. Y14 is 0, which is also correct. 21 is equal to Y12, which is also correct. But we did not have to calculate it if you have taken note of it. That's correct. All these 5 values. Now we need Y22. You can directly do these things. All the admittance is connected to bus 2. Just looking at the bus code and the admittances, meaning 1, 2 will come, 2, 3 will come, 2, 4 will come. So it's minus 2, 2, Y22. 3.66 minus J14.664, which is correct. And then 23 doesn't look correct. 23 does not look correct, while 24, instead of the equal sign, it should be plus, minus 1 plus J4. But 23, can you check 23? 23 is actually minus small y23, so it will be minus 0.664 plus J2664. Can you check that one? 23 y capital Y23 is equal to minus small y23. Small y23 is given directly, which is 0.667 minus J2664. So it's just the minus sign before will change. No, that's perfect. Thank you so much. And 23 is correct. Now we can go to 31. 31 is already there from 13. 31 is already there from 13. 32 is also from there from 23, which is going to be minus 0.667 plus J2.664. So that's 32. Now 33 for 33. Yes, 32 is correct. And for 33, what are the buses that are connected to 3? What are the lines that are connected to 3? That 1, 3, 2, 3, and 3, 4. 3 of them will come there. 1, 3, 2, 3. That will be 3.666 minus J14.664 or 5, which is correct. What you see on the chat, everyone can also look at the chat and get the values what Umeshan is putting there, and I'm double checking if they're correct or not. And Y33 is correct. Now we can go for Y34, which is given there, 2 minus J8. It will be just negative of that. So minus 2 plus J8 straight away from the table. So 34 will be minus 2 plus J8, right? So you can let me just type it for you. Y34 is equal to minus 2 plus J8. So we're done with the third row matrix, and then we can go for 4-1. 4-1 is already done. 1-4 we did, so it will be equal to 0. Y41 will be equal to 0. And 4-2 we have done. 2-4 we have done. 4-4 was minus 1 plus J4. So 4-2 will be equal to the same thing. And 4-3 we have also done it for 3-4, so we don't need to worry about that. Y44 is 3 minus J12, which is correct. So we have the admittance bus, right? So now the next step, we can go to the next step. So the next step is, let me add a new slide. The next step is to calculate the V21. So what we have now, we need to know the Q2, because in V2 equation there we need to know the Q2. If you remember, let me just ask you this one. So you see here, if you want to calculate V21, you need to know Q2. And for us here, we know the Q2. Because Q2 is falling within this constraint, we need to know the value first and then verify if it is falling within that or not. So if we go there to find out 2, 1, if I say V21, this one should be superscript. That's a problem now in PowerPoint. I'm putting this. Okay, it's not helping. I'm putting doesn't help. Let me just sorry. Yeah, that with bracket 1 within the bracket is the superscript. So V21, we need to find out. To find out V1, we need to know Q2 first. We need to know the Q2 first. So what we need to do now? So we have been given V2 is equal to 1.04, but we don't know the angle. So at 0D. Right, so we assume that at 0 degree to start. To start the calculation, we assuming delta 2 calculation, we assuming to be 0 because it's not defined, we can assume. So what is our equation? Your equation is P minus JQI is equal to, let me copy and paste that equation. This is the, sorry. So this is the power equation that we will need. We know that P plus JQ is a null conversion BI conjugate, but we are conjugate R equation. So if we put I is equal to 2, we get P2 minus JQ2 is equal to this. So remember condition like Ki cannot be equal to K here. It can be equal to, so V2 conjugate Y21 V1 Y22 times V2 Y23 times V3 Y24 times V4, that is coming from here, for K is equal to 1 to the number of buses, which is 4. So K is equal to 1 to 4 V1 V2 V3 V4, all those. So if we put all the values of admittances Y21 Y22 Y23 Y24 and the voltages V1 V2 V3 V4, we can find out what will be Q2. So we can, from this equation, equating, will equate imaginary parts on the either side and find Q2 is equal to what? Because we need to know Q2. If we equate the imaginary part, we'll find the Q2 value. Can you calculate? Anyone? Okay, let me help you. I got the value of Q2 is equal to 0.1102 per unit. You will verify it. You will need to do these intermediate steps by yourself. If you don't do that, then you will not learn how to get this value. You will need to do it by yourself. So Q2 is 0.1102. And if we go back to the condition that was given here, the constraints, sorry, if we use these constraints here, this is the constraints that are given here, meaning Q2 has to be in between 0.1 and 1.0, less than 1.0 and greater than equal to 0.1. What we found is 0.1102, which means Q2 is within the specified limit. It's in between 0.1 and 1.0, which is okay now. So we have the Q2 value now, and we can go for calculation of V21, but the angle delta is still to be 0 degrees because we still don't know the angle delta for the bus 2, meaning for V2. So we'll start with 0 degree. So we can calculate V21. So we can go to calculate V21 using the same formula like you used here. Same thing. We can copy this and put it in this new slide where we'll put the values. So we can use this formula once again, and then we can find out the value of V21. When we have done that, we will have the different if you get this value, let me know. We have all the admittances, we have the voltages P, Q. So we can put them in the equation and should be able to find out the magnitude of the voltage and angle. So if you don't have this, let me help you. Its value is what I have, 1.047 at 1.6 degree. So that's, now we have a value of the angle which was not given in the first place. It was just given as delta 2. So we have now V21, which is having both the magnitude and angle. V21, which is 1.047 at an angle 1.63. Similarly, if we go for calculating V31 using the formula that we have here, is the same formula. If we put all the values, now we will use V21 here. Can you see? We will use V21 here, not V2. 0. So V21 is calculated here. This 1.047 will come here. So we know the P3 Q3. We also know V3, which is given, and then we will calculate the value of V31. If you have different values than what I have, please let me know. So for V31, what I have is 0.9987 at minus 0.852. That's the V31. When we have the V31, we can go to use the same formula, which is for V41. V41 uses V31 that we have calculated here. V31 is calculated, so this V31 will come here. Before to start with, we will assume that it's 1 at an angle 0 degree. So if we put all the values, we will get the value of V41, which I have to help you. You need to do these things at home by yourself. I just want to say something on the test and assignment that you wanted to, that you are emailing me. 1.72. So that's the V41. That's the first part. And what we did in this one, we did not know the Q2 value. So what we did, we used the PQ equation, meaning P plus JQ if it is VI conjugate, but we are using V conjugate, so it's P minus JQ. For I is equal to 2, we put it there, and then we expand this equation, we get it. We put all the values of admittances and voltages, then we find out the value of Q2, and then we look back at the constraint, which is in between 0.1 and 1.0, and then we find that it is within the limit. So we carry on using Q as 1102. In this one, Q2 will be 0.1102, using Q2 equal to 0.1102. But now if we look at the second constraint, case number B, we come here for the second case. If we come here for the second case B, it doesn't fall within that. We got Q2 is equal to 0.1102. We got Q2 is equal to 0.1102. So it's outside. So what we should do, we should use the minimum value. So we use Q2 is equal to 0.2 as the minimum. It is falling on the minimum side. It is falling on the minimum side. For example, if you found that your Q2 value was 1.2, if Q2 value was 1.2, it's also outside the limit but on the maximum side. So we'll choose 1.0 in that case. So Q2 is chosen as 0.2 in this case, because that will make sure that we find out the values within the limit. Now let me put these values or I have, so that you can double check at home. if we use Q2 as 0.2, we should get V21 as 1.052 at an angle 1.55, and then V31, the V31 will be 1.002. You must do it at home by yourself, otherwise you'll never understand how it is going on. And for V3 it will be 9992 at an angle 1.33. So this is a bit different, where we were not given the Q value for the PV bus number 2. We had to determine it using the PQ equation, where we used V conjugate I formula, and then we expanded it. We put all the admittances and voltages, then we find out the Q2 value by the process of equating real power and imaginary power. We did not need to go for the real power because we needed to know the Q2. P was there, so we found the Q2, and then we go back to the constraint and we check it, and we find that it was within the limit. So we used that value that we calculated to follow the steps for calculating V2, V3 and V4. But again we come for the next constraint, which is between 0.2 and 1.0, and we find that 0.1102 is not within that limit, so we choose the minimum value, because 0.1102 is less than 0.2, so we choose that minimum. If our calculated value was, let's say, 1.3 or 1.2 or something greater than 1.0 or equal to 1.0, we would have chosen the value of Q2 to be 1.0. We just need to look at which side we are going far from, so we should choose that side. So using that Q2 value, we now can calculate all other voltages, V21, V31 and V41. Is that okay with everyone? Please let me know so I can just talk about the test and assignment. Many emails I'm receiving. Is that okay?
Yes, sir, it's okay.
Okay, thank you very much. So everyone must do this checking at home by yourself. So now so the test date was tomorrow, so it's postponed, but I will announce the date later on. Also about the assignment, we agreed that okay, it's delayed to by 1 week, but what I had thought is even more to help you, that I am going to put this date for the assignment on submission date on 12th Monday, and after that, no, there will be no catch up, no makeup, no nothing. Is that okay?
Yes, sir. Thank you.
So everyone must make note of this. This assignment date will be 12th Monday midnight, and after that there will be no catch up, no nothing. A lot of request emails I have to respond, but it's not a problem. But I give you more time. And for the tests, I will announce that as well soon, by probably next week, because I want to finish this chapter and something I want to start, then I will have the test. And for the quiz that you are typing, I found many were having challenges. I don't know how it happened. It ended up in a situation, I found almost 99% of you got 0 because of the grading there. I did not want that to happen, so I did not want to consider that mark to be 0. Honestly, it doesn't really make sense. So what I'll do with the quiz, next time I will just use simple method like we do for tests these days. You handwrite a short answer It will be not more than half a page or so if you handwrite, and then scan and submit within 10-15 minutes. I will do that, but obviously the question will be different one, but I will announce that one later on next week. So if you have anything in this regard, you can just let me know. Otherwise, we'll conclude this session. We continue tomorrow.
Sorry, sir, to disturb. Can you hear me?
Mhm.
Sir, just to confirm what you said right now, you said that if you are postponing the assignment for the 12th, there won't be any makeup test. Okay, I just wanted to.
No, then there will be no makeup submission of assignment, that particular assignment. You cannot, because I'm giving you extra days and days and days. After that, you wouldn't ask me, no one will ask me for, okay, I did not have time to do the.
Oh, I thought for the. Oh, okay.
I was not okay, I was not well, my laptop test, my catch up for that assignment. Because already catch up time, it is in April. Now, we are nowhere actually. And it's very concerning actually. In many ways, you wouldn't get it. The reason, I don't know, just give you one word. The admission to the CPZN is below 50% this year as compared to normal years. It goes, it's highly reflected in our society, at our household, everywhere within you and the pets where you go to study, where you go to study. When you go for the university or the school or college or whatever, you decide where you go. So it goes a big way and it sits in their minds and hearts and soul everywhere, which we probably really need to change. And how do we change? We change it by what we do. If we're doing things, they will know. If we're doing wrong things, they will know, and they will never recommend. And that probably is the reflection I told you that I bit about this, which should not be the case, in my opinion, or in my expectation. I always want students, how rich or where they come, they all must come to university and study. See the admission. Thank you so much.
Okay, thank you, sir.
Any other question?
Yes, sir. Can you hear me?
So I will, I will do those things. So have a great afternoon and meet tomorrow. Don't forget to practice this. If you don't practice, then you will never learn. You have to do these calculations. I gave you the answer. There are intermediate steps, not difficult, just you have to do it.